Welcome to Django REST Framework. My name is Chris, and I will be your guide. In this course, you will learn what is REST and how to use it, how to get started with the Django REST Framework, or DRF as it's known to its friends, and details on the various parts of the DRF, such as serializers, views, ViewSets, routers, permissions, and actions. A little bit of housekeeping before I get started. First off, this course assumes you are familiar with Django already. You will need to understand Django's models, views, URLs, and a little bit of administration files. If you're new to Django, you might want to check out other courses first. Some links to try are in the description below. Additionally, I'll be using the command line tool curl to visit certain URLs during demonstrations. If you're following along on the command line, you'll need curl installed. Depending on what operating system you're running, you may or may not have it already. If it isn't installed by default, you can get it at the URL here. The code samples shown inside of this course were tested with Python 3.9, Django 3.1.2, and Django REST Framework 3.12.1. There isn't anything that I'm doing here that is particularly version dependent, but if you run into some little weird corner case, that might be why. One final note, as part of our process at RealPython, all the code here has been formatted with black. The reason I bring this up is because the default code generated by Django's admin command is not black compliant. So if you're comparing what you're seeing on my screen with your own settings file, you may notice some presentation differences, and that's because black has changed it. The Django REST framework is, of course, all about REST. REST is a protocol used to send data back and forth between servers. It's the standard that isn't a standard. You can think of it as a protocol guideline, a set of ideas that are commonly used across a lot of interfaces, but not as codified as something like SOAP. REST is built on top of existing HTTP methods and URLs, and this is how you can be a standard without being a standard. The underlying concepts in it are standards. The HTTP methods are used to do things like list available objects, get details on an object, create an object, update an object, patch an object. The difference between updating and patching is whether or not you have to provide all of the fields for an object, and finally, deleting an object. The format of the data sent back and forth in the body of the REST command is up to the implementer. The most common mechanisms for serializing data are JSON and XML. The Django REST framework is a Django library that takes the concepts in REST and ties them to the models and views inside of Django. For each of the major concepts inside of Django, like views, models, and URLs, the DRF provides REST variants on these. First off, Django models get paired with DRF serializers. The serializers specify how to turn the content of a Django model into JSON or XML to be sent to a client. DRF views and ViewSets are specialized Django views used to control what REST protocol mechanisms are exposed through your API. Like Django URLs, DRF routers map the views to the actual URLs exposed. Out of the box, DRF supports a variety of data rendering interfaces, the most popular being JSON. Other mechanisms are also supported, as well as there being third-party libraries. In addition to regular data like JSON, DRF also comes with a handy web tool that can be useful when you're debugging. All of this is tied together with a handy permission structure to make sure that you're only exposing the data that you mean to. In the next lesson, I'll give you an overview of REST in order to help you get started. In the previous lesson, I gave you an overview of the course. In this lesson, I'm going to introduce you to the concepts behind REST. REST stands for Representational State Transfer. I promise that's probably the only time you will hear that. It comes out of a PhD dissertation by Roy Fielding from just over 20 years ago. Dr. Fielding defined the REST protocol based on the HTTP standard at the time, making it something that could be implemented without making changes to the network. Anyone who could run a web server could run the REST protocol. Not surprisingly, for a PhD dissertation, it reads a bit like a PhD dissertation. It contains 6 architectural constraints that define the protocol. The first is client-server architecture. This is the idea that there's a separation between the UI and the data storage and processing. As HTTP is already client-server, this fits nicely. The second constraint is statelessness. No client context is stored on the server between calls. The client has the only context. Any call should be repeatable on the server. HTTP is already this way. In fact, cookies were created inside of the HTTP protocol to get around this fact. The third constraint is cacheability. The protocol needs to be able to support caching on the client side. Once again, this maps very nicely to web servers. Web servers already introduce cache headers to indicate whether or not data has changed on the server side. The system must be layered. This means that things like proxies and load balancers could be between the client and the server and should not affect the client or the calls. The fifth constraint is the ability to have code on demand. I've never actually seen this one used with REST, but it is possible. This is similar to the idea of having HTML and JavaScript come down with a web page, both data, UI, and code in that case. The sixth constraint, a uniform interface, breaks down into 4 properties. The first is resources are identified as requests. Essentially, URLs are what specify the data. The uniqueness of the URL specifies the uniqueness of an item of data. Secondly, resource manipulation through representation. Data itself has enough info to modify or delete the data. The data is self-contained. This is usually implemented through the use of URLs. So the data corresponds to a URL, and you can use that URL to do things like change the data or delete the data on the server side. The data is intended to be self-descriptive. If there's information that is needed about the encoding of the message, it is included in the message. This is similar to the accepted types header inside of HTTP, which indicates what kind of encoding the client supports. And finally, the rather dubious acronym HATES, Hypermedia as the engine of application state. This means links are how you do things. Data should contain links that specify how to manipulate that data. This aspect is one of those that's often ignored. I've seen plenty of REST-like protocols that only use ID numbers inside of the data rather than full URLs. But there is an advantage to embedding the URL. It makes it very simple to go back to the server and get more information simply by using the associated URL. In the overview, I mentioned that REST is the protocol that isn't quite a standard. The code is more what you'd call guidelines than actual rules. I really probably should have done that in my best pirate voice. R. In practice, what this means is every implementation is a little bit different. Oftentimes, only a subset of REST is implemented. When I first started writing REST interfaces, I very seldom implemented the entire protocol. Frequently, I was just doing XML over HTTP, using GET to get the data, which is REST-like, but not bothering with all the puts and patches and other things. For example, using POST to make changes, which isn't quite REST compliant. This lack of adherence to a standard sounds like it might be a problem. How are you going to know what to do? Because the protocol is based on top of HTTP, you don't need any fancy libraries in order to access it. Any library that supports HTTP supports the use of REST. As a result, client-specific code ends up being just that, client-specific code. So whether or not the implementer used POST correctly isn't going to matter very much because you're going to have to look up the API's documentation as to how to talk to it anyways. This allows a rather lazy approach to your coding in the fact that the clients only have to implement the minimum necessary to access your API and nothing more. The good news about this is it makes REST far more lightweight than similar technologies that are all-encompassing like SOAP. The bad news about this is sometimes you have to pay a little more attention to the documentation to know how you're going to use it. You can get away with this being so ill-defined because REST is built on top of well-known standards like HTTP. If you've done any web programming, you're probably already familiar with the idea of HTTP GET and POST. REST uses these as well as other HTTP methods. Let me run through the different kinds. As I mentioned, GET. The most common one, this is what happens when your browser goes and fetches a web page. It's getting the web page over HTTP. The GET method inside of REST is used to either get a single resource with a fully qualified URL, usually including an identifier, or to get a listing of resources. POST is used to create a resource. In the web world, POST is used for submitting forms. The body of the post contains the fields of the form. In the REST world, the POST is used to create a new object. Those same fields are used to specify the fields of the object that's being created. The URL that you're posting to specifies what object is being created. Put is somewhat like POST. It uses the fields to specify information about the object, but in this case, it's to update the object. Patch also is used to update the object. The difference between put and patch is that put requires you to specify all of the fields and replaces them in the object. Patch allows you to specify only a subset of fields and only changes those fields that are given. And finally, delete, obviously enough, deletes the object on the server side. Let me run you through some examples. Here's a URL that if you call the GET method on, will retrieve a list of books. Further refining the URL to specify an ID and doing a GET will not get all of the books, but a specific book, in this case, the book with ID 12. Posting to the books URL will create a new book. The body of the post contains fields title and author to specify the title and author of the book that is created. Typically, the REST protocol will return the object that was created with its ID information. Post goes just to books. Put goes to a specific book, in this case, book number 23, the book that was created in my last example. Similar to post, you specify fields, the title and the author. In this example, the title is the same as that which was created in the previous one, but the author's been changed. Because it's a put, I have to specify all of the fields. Here's a patch on the same thing. Put requires all of the fields. Attach only requires the fields that I'm changing. So again, I'm specifying book 23, but this time only specifying the title. The author will stay Franz Kafka, and the title will change from Metamorphosis to The Metamorphosis. And finally, here's a delete. Similar to a get, it specifies a URL that fully qualifies the book. In this case, I'm deleting book number 12. The REST protocol does not specify the format of the payload. The most common payloads are JSON and XML. The DRF, which the rest of this course is about, supports these out of the box, and there are third-party packages that you can use to add on to the DRF to support other ones as well. A popular one adds YAML as a payload. Let me show you an example of what a JSON payload looks like. Here, I'm using the curl command to fetch a list of books. The -s parameter specifies silence. This stops curl from showing the progress information. The URL that I'm hitting is the local host on port 8000, for example, on my own little Django server, and the path that I'm hitting in the URL is books, because I want a list of books. Normally, what comes back from the server is an undifferentiated JSON blob. That tends to be hard to read because it's all in the same line, so I'm going to augment this command with a pretty printer. There are a whole bunch of different programs you can use to pretty print JSON, but seeing this is a Python course, I'm pretty sure you've got Python installed. You can use Python's JSON module directly to pretty print. Calling python-m here specifies to run the JSON tool module. The JSON tool module will take whatever's passed in on standard in this case from the pipe, will pretty print it and put it to standard out, the screen. So I run the command and I get the following result. Here's some pretty printed JSON, which includes a dictionary. The dictionary has one attribute, which is books. The books attribute is an array that contains two books, the Metamorphosis and the Stranger. Obviously, I was in a bit of an existential mood when I wrote this. That's the basics of REST. Next up, I'll dive into what you're actually here for, the Django REST framework. In the previous lesson, I gave you an overview of REST. In this lesson, I'll give you an introduction to the Django REST framework, concentrating on the serialization and view mechanisms. The Django REST framework is a toolkit for developing web APIs built on top of the Django platform. It integrates with Django models, views, and URL patterns. It provides classes called serializers for turning your Django models into JSON or XML or whatever else you're going to use for your payload, views for controlling what can and can't be seen in your API, and tools to tie into the URLs to specify where your objects live and how to access them. Are you like me and prefer function-based views over class-based views? Or are you one of those folks who are the other way around? No worries, DRF provides a way to handle either case. The serialization toolkits inside of the DRF are most powerful when paired with Django models, but they don't have to be tied to a Django model. You can also serialize non-ORM-based data. And to assist with your debugging, one of the payloads is a web-based interface. You can use the web to interact with the API, examine the payloads that come back, and initiate the different HTTP calls to manipulate objects on the server. Full documentation and tutorials can be found at djangorestframework.org. Not surprisingly, the Django REST framework is built on top of Django, so you'll need both Django and the Django REST framework installed to be able to follow along with this course. As is best practice in the Python world, it's better if you do this inside of a virtual environment. Here's the pip command to install both Django and the Django REST framework. Note that Django REST framework is all one word. Most Django pip modules usually have underscores in them. For some reason, the DRF folks decided not to follow this convention. If you run this command, you'll get a long list of output as Django, DRF, and all of their dependencies gets installed. I'll be using the command line tool curl to show you some of the results coming out of the DRF. Curl comes built in with most operating systems, but in case it doesn't come with yours, you can get it at curl.hacks.se. Don't forget that all the code that I show you inside of this course is available in the supporting material dropdown. It can save you a fair amount of typing if you just grab that zip file and follow along. I'm going to start by setting up a sample Django project, which I'll then use to demonstrate the DRF. First off, I'm going to use the Django command to start a new project called FEDORA. Go into the FEDORA directory, and you'll see the clean installation of the FEDORA directory with settings and URLs, etc., as well as the manage.py command. Next thing that I want to do is create a super user. Before I do that, I need to deal with the database so that the auth tables are built. So I'm going to run migrate. And now that that is done, I'm going to create a super user. Because this is just for me, I'm going to cheat on the password so that I don't have to type anything complicated in. And so Django warns me. Now that I've got the application and the super user, I'm going to create an app inside of Fedora called People. Here's what the directory looks like now. I've got the Fedora directory, I've got a database, I've still got the manage.py, and the newly created People app. Now that I have the project created and the people app created, I need to update the FEDORA settings.py file to make a couple small changes. I'm not showing you the entire settings file here, just the sections that I need to change. First off, I'm going to modify the allowed hosts listing to include local hosts so that I can hit it from my browser when I'm using the Django development server, adding both versions of localhost. And secondly, I need to register the two apps. I need to register Django REST Framework and the newly created people app. First, the Django REST Framework, which oddly enough has the underscore in it, even though the PyPI module doesn't, and the newly created people app. That's all the changes for the settings file. Now that everything's set up, let's start writing some code. First off, I'm going to create a person object for the database using a Django model. I'm going to keep the model fairly simple here with 3 fields: first name, last name, and title. And then, because I'm anal retentive and I don't like persons showing up in the Django admin, I'm going to update the meta value to people. Here's the first bit of DRF code. Create a file called serializers.py inside of the people app. This file is the pair of the model. Typically what happens is with every model you create, you also create a serializer. The serializer specifies how to turn the model into the payload data for REST. By convention, the serializers are named the same thing as the models. So here on line 5, you see me declare person serializer to serialize my person object from the models file. Similar to how a person inherits from model, the serializer inherits from the model serializer. Model serializers do a whole bunch of work for you. They automatically look at the model that's associated with them and know how to serialize the different kinds of fields. There's all sorts of control you can do here to get fancy, and I'll show you that in later lessons. But for now, all I want to do is serialize the model as it is. I have to do 2 things inside of the meta section. Specify the model this is associated with, which in this case is person, and the fields that I am going to serialize: ID, first, last, and title. And that's all I need to do. Serialization is now ready to go. The DRF will take care of the rest of turning the model into a payload. Serializers themselves are only responsible for turning models into payloads. They don't actually create the views or map to the URLs. The DRF uses the same kind of patterns as Django. So now I'm editing the people views file, and I'm going to create a new view. This is on line 9, list people. What this is going to do is list all of the people in the database, serialize each one of them, and return a payload with a listing of all of the people. Line 8 is a decorator from DRF that tells DRF that this is going to be associated with the HTTP GET method. DRF supports all of the HTTP methods supported by REST, so I can create views using the API view decorator tied to any one of those HTTP methods. Notice that it takes a list. You can actually have it associated with multiple HTTP methods if you desire. On line 10, I get a query set of all of my people. On line 11, I instantiate the person serializer defined in the previous file, passing in the query set and the variable many set to true. The serializer is capable of serializing more than one object at a time. By passing in the entire people query set with all the people objects in it and many equals true, I will get all the data serialized for every one of the people in the query set. Similar to an HTTP response object, DRF has its own response object. It takes a content dictionary. In this case, I'm defining the content to have a single key named people and the data associated with the serializer. Creating the payload is a 2-step process. The first step is instantiating a serializer with your query set, and the second step is referencing the data property and putting it into the response object. The view I've just shown you is a Django view like any other, and as such, I need to register it inside of the URLs file. I'm going to do this by creating a URLs file inside of people, and I'm going to specify a path called list people, associating that with the view that I just created. You're going to need something to serialize, of course, otherwise your payload will just be empty. In order to make that easy, I've created a person admin object with the first, last, and title fields so that I can go into the Django admin and create some data in the database. Okay, I'm almost all set now. The last thing I need to do is just register the people URLs with the global FEDORA URLs. There are a couple things I have to do to this file. First off, I have to update line 3 to include the include function, because I'm going to include all of the people URLs. Secondly, I'm going to create a path called people and include all of the people URLs file. Now you'll be able to hit the development server with the path people/list people included from the apps URLs file. Okay, all the code's set up, almost ready to go. I need to register the database changes with the make migrations command. It found people and registered it. Now I need to migrate that. Great, the database is all set up. And in order to be able to demo, I'm going to have to actually have some data in the database. I'm going to run the Django development server and show you the admin right now. Off screen, I'm running the Django development server, and here in my trusty web browser, I'm going to open up the admin URL. That's localhost/admin. I'm going to log in with admin, and the super secret 5-letter password I created earlier begins with A and rhymes with admin. And here I am inside of the Django admin. I'm going to add a few people by clicking on the add button. And here are my 4 people for the database. Or if you don't feel like doing all of that, I managed to save all of that in a fixture for you, so you can run the load data command. Either way, you've now got some data in the database with some people. Running the Django server. And then I'm going to switch to the lower window and hit that server with curl. First off, localhost port 8000 people list people, the view that I just created a few minutes ago. The response that comes back is in JSON. It's a dictionary with the single key people and an array of the 4 people I created in the database. In the upper window, you can see the get that was executed. The URL people list people was hit, and that translated into the list people view that I created in the views.py file in the people app. Because that's a little hard to see, I'm going to do that again for you, but this time in a full window. Here's the curl command. I'm using -s so that I don't get the progress bar as I go along. I'm hitting the same URL, port 8000 on localhost, people list people, and then as I did in the previous lesson, I'm going to pipe this through Python using the JSON tools module to pretty print the result. Let me just scroll up here for you. What comes back is a dictionary with a single attribute of people and the 4 people that I created in the dictionary. That kind of feels like a lot, but most of what I did there was just typical Django stuff. Let me just quickly review what I had to do. First off, I created the project and the app inside the project. Secondly, I created a person model, no different than I would create any model inside of a Django application. The first DRF specific thing I did was create the person serializer, which maps the person model object to a REST payload. I then created a view that uses a DRF response object to send a serialization of the person.objects.all query set down in the payload of REST. And finally, I had to register this view as a URL like any other view in Django. If you're new to Django, there was a lot to follow along there. If Django's old hat for you, there was very little extra code that you had to do to take your typical Django application and make it a REST-capable one. So far, I've shown you the simplest possible view. The ViewSets mechanism in DRF gives you a lot of power to do a lot of REST stuff with very little code. Next up, I'll introduce you to ViewSets. In the previous lesson, I talked about the Django REST framework serialization mechanism and how to use the API view decorator to create a view. In this lesson, I'm going to be drilling down more on views and introducing the DRF ViewSets class. As a quick refresher, here are the DRF components so far. You've seen the serializer. The serializer is responsible for taking an object and turning it into a text payload, or also to take text payloads and turning them back into objects. Most of the time, you're going to want to do this with a Django model, but it doesn't have to be. The entry point for your REST call is a view, just like a regular Django view. The DRF provides decorators to make this a little easier. The heart of it is you have to return a DRF response object with your serialized data inside of it for what to respond to with the view. To make your life easier, the DRF also has a concept called ViewSets. A ViewSet is a class that encapsulates the common REST HTTP method calls, things like the gets, the posts, the patches, etc. Using a ViewSet makes it far faster to implement a series of REST calls on a class of objects. Going with ViewSets is the concept of a router. A router allows you to use a ViewSet to declare a series of URLs. This means you have far less work to do. You just map the ViewSet to a router, and the DRF takes care of the rest of it for you. Here's an example base ViewSet taken straight out of the DRF docs. As you can see, it declares 6 methods on the ViewSet class: list, create, retrieve, update, partial update, and destroy. List maps to the get method for listing the objects. This would be used to do something similar to the people list view that I showed you in the previous lesson. Create maps to the post, allowing you to create a new object. Retrieve maps to the get, but for a specific identifier, so to get book number 12. Update maps to HTTP put, taking an object as well as some fields, those fields updating the values inside of the object specified. Partial update maps to patch, taking an object as well as a subset of fields, only updating those fields that are given. And destroy maps to the HTTP delete method. Throughout this course, I'm going to continue building on the FEDORA project. For the most part, I'm going to create a new app for each lesson. I won't stepwise go through the process of creating each app. I will just quickly summarize it in order to save time. If you need guidance on how to do this, see the previous lesson or dig into one of the other Django courses. To get going for this lesson, I'm going to create another app, this one called Artifacts. I'm going to have to edit the settings.py file, adding artifacts to the installed apps list. I'm going to have to edit the FEDORA URLs file to add the artifacts URLs file in the URLs pattern list. And then for the rest of this lesson, I'm going to show you the contents of models.py, serializers.py, views.py, and URLs.py. You can code along with me as I go. In order to play with the REST interface, you're going to need some data. So you can either create an admin.py file to go with the models.py, or you can use the one supplied in the supplemental materials. Don't forget to run make migrations and migrate as necessary, and then use the admin or load data command to add some data to play with. Inside of your newly created Artifacts app, edit the models.py file and add this code. What I've done here is created a new Django model called Artifact. It has two fields, a character field for name and a Boolean field to indicate whether or not the artifact is shiny. Like before, I need a serializer. Inside of a new file called serializers.py, I'm creating the artifact serializer. As in the previous lesson, all I need to do here is identify the model that's being serialized, which in this case is the artifact, and the list of fields that I want serialized. The DRF provides a handy shortcut. Instead of fields being a list, you can give it the string $all, and all the fields in the artifact will be serialized. The DRF is all about making your life easier and writing less code. Instead of writing a view, this time I'm going to write a ViewSet. A ViewSet is a view class, and to keep things short and sweet, all you have to do is provide the serializer that you want associated with the ViewSet and the query set associated with that serializer, and the DRF will create everything else for you. So on line 7, by convention, I name it the artifact ViewSet. You'll notice this pattern seems to hold. Artifact serializer goes with our artifact model. This inherits from the model ViewSet class. On line 8, I specify the serializer class, which is the artifact serializer. And on line 10 and 11, I override the getQuerySet method, returning the query set of what I want. In this case, it's all of the artifact objects. Essentially, I'm accomplishing the same kind of thing that I did with the people list in the previous lesson. I'm listing off all of the artifacts, but this time, because I'm implementing the model ViewSet, not only am I getting the get for the listing, I'm also provided with retrieves, deletes, creates, and both kinds of updates. To wire this ViewSet into the system, I use a router. Inside of artifacts URLs.py, on line 7, I create a default router, and on line 8, I register this router. I'm registering the artifact ViewSet under the name artifacts. This means it'll be listed under the path artifacts wherever my URL is mounted. By using this router, I don't have to specify routes for all the different URLs for creates and posts and patches. I just have to register the router, and then on line 11, include that router. In a separate window, I'm running the Django development server. Now I'm going to demonstrate hitting those REST URLs with curl. First off, a simple get. I'm hitting localhost port 8000 under artifacts and piping it through JSON tools to get a pretty print. And what I get back is a dictionary with artifacts and a URL that says go to artifacts/artifacts. This happens because of the way I set up the router. The first artifacts in that URL is part of the path from my include. The second artifacts in that URL is placed there from the registration of the router. In later lessons, after you've registered a bunch of different routers, this listing will be helpful. It gives the developer information about all the possible object routers that are available. Right now it seems a little redundant because there's only one thing in there. But I'll take the hint, I'll use that dictionary and get that first URL. Once again with curl, piping it through the JSON tool, and there you go. This is the get for the artifacts/artifacts path. It returns 2 artifacts from the database. Notice it's just a list in this case. There's no dictionary to go with it. I can also do a get on a specific value from the database by appending the ID of the object to the previous URL. Still a get. Same localhost, same port, this time with ID 1. And what is returned is just the information about that specific object. So far, so good. Now let's do a create. The -X parameter to curl tells it to use a different kind of HTTP method, and -D are fields to pass in. In this case, I'm passing in the name and shiny fields. It hits the URL. It's a bit of a long command line there, so notice that it's wrapped around to the second line. And what comes back is JSON of the new item created, the Ark of the Covenant, with shiny, of course, being true. This time I didn't pass it through the pretty printer, so it just gets spit out all in one line. If I run the listing again, you'll notice that the Ark of the Covenant has been added to our list of artifacts. Now let's do an update. Once again, using the -X, this time using the HTTP put method, specifying fields for golden idol and shiny true, and the full URL of the object that I'm replacing, object 1. This renames the Chachapoyan fertility idol to the easier to say golden idol. As with the post, what comes back is the object that was changed. Let me try the same thing, but with a subset of the fields, this time only specifying shiny. I get back an error from the server. Notice that this error is similar to how a Django form field works. If you fail to specify a required field in a Django form, Django gives you error information about what field failed. Django REST framework is doing the same thing here. Because I used a put, and a put maps to an update, you have to provide all fields for an update, and because I failed to provide the name field, I get back a dictionary with an error that says the name is required. If I only want to update the single field, instead of using a put, I have to use a patch. Similar concept here, this time using HTTP patch, provide only the shiny field, and same URL. And this time it worked. I don't know what Balak did to that pretty little gold statue to make it no longer shiny, but the database reflects it now. The only HTTP method left is delete, so here it goes. Once again, -X, this time with delete. Specify a URL that has a specific object. In this case, you get nothing back from the server. If I run the listing get again, you'll see that the golden idol is no longer there. I guess Balak took it out of inventory. By using a view set instead of a view, you automatically get the list, retrieve, create, update, partial update, and delete methods for your object. In just a couple lines of code, you've fully defined a REST interface for your object. This is extremely convenient and shows off the power of the DRF. Normally, I'm a views should be functions kind of guy, but when I use the DRF, ViewSets are the way to go. In addition to the convenience of having the ViewSet define all of those things, the router means you don't have to define the mappings for all of those. List, retrieve, create, update, partial update, and delete are all created by the router in a single line. The DRF saves you an awful lot of work and an awful lot of definition. Everything's about the shortcuts here. So that was ViewSets. Next up, I'll show you the web interface, a great way to debug your REST application. In the previous lesson, I introduced you to DRF ViewSets. In this lesson, I'm going to show you the built-in web interface and explain how renderers work. Built into the DRF is a web interface. The same URLs I've been showing you in previous lessons, if you hit those with a web browser instead of something like curl, you'll get a full HTML page, including the payload and the ability to run actions on the objects. How does DRF know what to respond with? Well, there's two answers to that question. First, what renderers are installed? And second, what HTTP accept headers are sent. For example, if you had a YAML and an HTML renderer installed, and your program sent the following accept header, accepting JSON, indented JSON, YAML, HTML, and everything else, then YAML would be used because it's the first renderer that matches that accept string. Up until now, when I've been using curl in the demonstration, curl by default accepts ***, so it hits the first renderer installed, which by default is the JSON renderer. You can affect what renderers are used by changing a setting in settings.py. Declare the REST framework dictionary with a default renderer classes attribute, and that specifies what renderers to use. What's showing here is actually the default. If you don't specify anything in settings.py, this will be what you get. This says to use the JSON renderer and then the web API renderer. As I mentioned, curl accepts everything, and because JSON renderer is declared first, this will be what matches. In a production system, you may not want to use these default renderers. As an example, the web renderer will download all sorts of options for choice fields. So if you have a field with thousands of possible choices available to it, the browser will download this every single time. By making the web renderer available, you are potentially opening yourself up to a denial of service attack. It's very handy to have this renderer when you're debugging, but it's not a bad idea to turn it off once you go into production. The web renderer also makes your API far more discoverable. A lot of information is presented. Now, all of that information is still queryable through other renderers, but it makes it easier to find. Security through obscurity isn't a valid approach, but why make it easy on people? In addition to setting the renderer inside of settings.py at a global level, you can also set it specifically. For example, in a view class, you can use the renderer class's decorator to specify what renderers are valid with a view. This one only supports the JSON renderer. Notice that the parameter to the decorator is a list, so you can specify multiple renderers if you wish. Alternatively, you can also set it inside of a view set. View sets inherit from API view class, and all API view classes support an attribute called renderer classes. This is similar to using the decorator in the previous example, but it sets the renderer for all of the actions associated with this view set. The DRF comes with a bunch of different choices for renderers. You've seen the JSON renderer already. The template HTML renderer uses Django's template engine to render whatever template you pass it. The static HTML renderer takes a string, which is supposed to contain HTML. You still use the DRF response object, but in this case you pass it the string that you want rendered. The browsable API renderer is the web renderer, which I've been talking about and will show you shortly. The admin renderer is similar to the browsable API renderer, but the interface looks like the Django admin instead of the default. The HTML form renderer renders a HTML form object. Typically, this isn't used on its own, but used in conjunction with a template, which is then fetching a form. The forms are then based on the body of the REST elements. The multi-part renderer is another one that isn't used on its own. This is also for forms, but in this case multi-part forms, and typically is only used for testing. In addition to all of those, there are a whole bunch of third-party packages as well, supporting YAML, XML. If you're not happy with the format of the JSON, there's multiple different types of JSON, so you can make it look just about however you like. Message pack, Excel, CSV files, a variety of Panda-based plugins, which support CSV, Excel, and PNG, and LaTeX, of all things. The DRF renderer system has been built so that you can customize it and create your own. If you want to look into this, you can look at the API guide in the renderer section. And now, let me demo the web interface. In a window off screen, I'm running the Django dev server. I'm going to hit the same artifacts URL that I showed you with curl in the previous lesson. And here's the web interface. The API root view is whatever you defined inside of the default router. At the moment, all I have defined is the artifacts section. Down here in the body of the response, you see the headers that came back, as well as the payload. This is just like the curl view before, but has the added benefit of the link is now clickable. Clicking the link gives me the retrieve method, the list of artifacts, in this case showing the 2 artifacts that are in the database. If I scroll down, there's a form that complies with the artifact serializer. Clicking post will call the create method in REST. The end result on the screen is the newly created object, with ID 3, name golden idle, and shiny set to true. In the breadcrumbs at the top, I can go back to the artifact list, and now you'll notice I've got 3 objects in the database. I can modify the URL at the top and specify a particular ID doing a retrieve. And here you are back at the detail information for artifact 3. Notice this allow header tells you just what HTTP methods are available for this particular object. Because the artifact view set was default, it supports all of the possible HTTP methods. Scrolling down once again, I can change the form, click on put, and this will cause an update to happen. Just like before, I've changed the artifact from shiny to not so shiny. Along the top, there's a delete button so that I can call the delete method. It confirms, which I approve, and it tells me that the object has been deleted. Notice that the URL is still for object number 3, but there's no information here because there's no content for object number 3. Clicking back on the artifact list, I'm back to having just the 2 objects. If you're tired of the web interface and want to see exactly what comes back, you can change the format of the get using this button on the right-hand side. By selecting JSON, the page now comes back as JSON. This particular view is what Firefox does with JSON. Clicking on raw data shows you what actually came back. As you can see, this is a really powerful and useful tool. I use it almost continually whenever I'm trying to debug my REST APIs. That's it for the web interface. Next up, I'll show you how to control access using DRF permissions. In the previous lesson, I showed you the DRF web interface and renderers. In this and the next lesson, I'm going to be talking about the DRF permissions. The Django REST framework has a robust permission mechanism. The most common usage of it is tied to your view sets. You can specify permissions at both the request level and at the object level. An example of request would be whether or not you're logged in. An example of the object is whether or not you are able to look at or change that particular object. In order to demonstrate DRF permissions, I'm going to have to set up a whole bunch of Django auth pieces. I'm going to spend this lesson prepping and the next lesson diving into the actual DRF permissions. If you are very comfortable with Django auth, logins, creating login screens, and creating accounts, you can skip this lesson and not worry about it. If the Django contrib auth module is new to you, then you might want to stick around. Everything that I show you inside of this lesson is moving towards the fact that I need a couple more accounts than just the admin account. I'm going to create an account called Indy that has the staff setting set to true, and another account called Marion that's just general usage. Out of the box, Django no longer comes with a login page. In order to be able to play with this and have accounts log in and log out, I'm going to need to create a login page to go with these accounts. This lesson is going to be just a short review on how these pieces work. If you want to see details on how to use the Django auth library, this article could be of use to you. The first change I want to make isn't really necessary, but it will make your life a little easier. Inside of FEDORA settings, you'll find a definition for auth password validators. This specifies what password validators Django runs when you create an account. Because I'm just going to be messing around and I don't want to have to deal with this, I'm going to zero all this out. This is generally a bad idea. You're breaking built-in security. But, it's just between us friends, so I'm getting rid of that. The second thing I need to do is create a login page. That's going to be rendered as a Django template. In order to do that, I'm going to need a templates directory. So I'm going to make that inside of the FEDORA project. The template itself has to go in a directory called registration. So inside of the templates directory, I'm going to create another directory called registration. Once those directories exist, I'm back into FEDORA settings, and I need to tell Django to look in those directories for some template content. Look for the templates definition and change the value for the DIRs key. It needs to be changed to point to that template directory. Base dir is defined near the top of the settings file and specifies where the project exists, so templates is relative to that base dir. If you happen to be using an older version of Django, do note that Django 3 uses the path module. This base dir is defined as a path. In Django 2 and before, this would have been an os.path.join call. While I've got settings open, I also want to make one more change. I'm going to tell Django where to go if someone logs in and they aren't explicitly told to go somewhere. So this is the default definition for a logged in user. I'm going to set that to a view called library. Django provides views for doing authentication, but does not include them by default. So I'm updating the Fedora URLs file to include the URLs for those views. They're in the contrib auth module, and I'm going to include them under a path called accounts. Finally, I need the actual template for the login page. I'm going to create the world's simplest login HTML. It's not very pretty, it really just has the form in it, but this will do the job. This HTML code goes inside of a file called login.html inside of that newly created templates/registration directory. The contrib auth module automatically looks for a template with this name, and that's how these pieces are wired together. With all that set up, I'm now ready to use the Django admin to create a couple of accounts. In a window off screen, I'm running the Django development server, and now I'm going to point the browser at localhost/admin. Once again, logging in with my super secret password. And now, in order to create two accounts, I'm going to click on the add button for the users. The first account I'm going to create is for Indy. I type in the username and passwords, being grateful that I turned off the validators. And when I hit save, the admin will let me edit this newly created account. Indy was added successfully. I'm going to scroll down to permissions, make Indy staff, and save. And you can see that Indy has been added. Adding one more user. Because I don't need to make any more changes for Marion, I can just scroll down to the bottom and save. As you can see here in the listing, Indy is staff and Marion is not. Great, now that you've got those accounts, you're all set to see how the DRF and permissions actually work, coming up in the next lesson. In the previous lesson, I gave a quick review of the Django Authentication module. In this lesson, I'm going to use the accounts created in the previous lesson to show you how DRF permissions work. In case you skipped the previous lesson, I'll just quickly run through what I did. I installed the Django Contrib Auth module. I added a login page, and I created two accounts, one called Indy with the staff parameter set to true, and one called Marion. Okay, the background's in place now. I've got some accounts so that I can show you who can do what with different permissions. Now I'm going to add another app for books. This will be where I demonstrate the permissions. If you're writing the code yourself while you're following along, you're going to need to change the settings file to add books to the installed apps, change the URLs file to include books.urls, and then create the files that I'm going to show you for your models, serializers, views, and URLs. Like before, you'll need to create your own admin file or pick one from the supplementing materials if you wish to use the admin to create your data. You'll need to run make migrations and migrate as necessary on the models, and then use the admin or a load data command to get data in so that you can play with the REST content. Here's the model file for my newly created Books app. I'm creating an ORM class called Book that has two fields, title, the title of the book, and whether or not the book is restricted, which is a Boolean. Similar to the artifacts, I'm going to create a book serializer. It's the minimum possible serializer, taking everything in the book model and serializing it. Inside of the book app's URLs file, I'm going to do two things. First, I'm going to register a router for the book ViewSet, which I'll be defining shortly. That router is defined on line 8 and then included on line 11. And then on line 12, I'm also adding a view, which is the home view for this area. You may recall that inside of the settings file, I set the login redirect to be books/library. Well, there's going to need to be a view there, so I'm setting the path up for that now. And now here's the views file. It's a little longer than things from before. First off, let me scroll down a little bit to show you the home view, the library method. This method's pretty simple. All it does is output some static HTML. This is pretty bad practice. You should be using template files inside of Django, but it's easier to just show it to you this way. What this home page will do is show you who is logged in, provide a link to the REST API, and a link for logging out. All of that will be rather useful when I try to demo this shortly. Secondly, I'm setting up a book view set. The only difference between this and the artifacts view set is the newly added permission classes attribute. Permission classes takes a list. In this case, I'm passing in the isAuthenticated class. Let me just scroll up for a second. IsAuthenticated comes from REST Framework Permissions. With this permission class in place, the book view set will only be visible to people who are authenticated via Django. Here I am back inside of the admin. I'm going to go to the logout link and log out of the account. Now, let me visit the books/library URL. The library page home view requires you to be logged in. As a result, it redirected me to the login page, which I created inside of the templates directory before. Now I'm going to log in as Indy, and here I am at that library homepage. It shows me that I'm logged in as Indy and provides a link to the Books API. Let me visit that. And here's the result, the listing of books. Going back to the library page, logging out, and then going straight to the books listing. And you'll notice what comes back from the REST API is a permission denied. I'm not logged in, so it doesn't let me see the list. So far, so good. IsAuthenticated stops anyone who isn't authenticated from seeing your REST API. Let's experiment a little bit. I want to change the permission class. Right now, it's isAuthenticated. Let's change that to something else. Here's isAdminUser, also part of the DRF Permissions library. Going back to the same books entry point. Still not authenticated. That makes sense because I still haven't logged in. Now, visiting the login page, logging in as admin, and there's my Books API. So far, so good. Let me go back, log out. This time I'm going to log in as Indy. Here I am as Indy, visiting the Books API. Uh-oh, that's not quite what I had planned. It turns out that DRF's isAdmin really means isStaff. Because the admin account is both a super user and staff, it's allowed in. And because Indy is staff, he's allowed in. If I logged in with Marion, it would forbid me because she's neither. So let's make some changes to the code to fix that. I'm back inside of views.py, And now I'm going to add my own custom permission class. This is called isSuperUser, and it inherits from the base permission class. It has one method, which is hasPermission, and inside of that, I'm going to look at the request object, the user who's associated with the request object, and I'm going to check the isSuperUser property and return that as the value for hasPermission. Now, if the user is a super user, they'll be allowed in, and if they're not, they won't. So in this case, Indy, who's only staff, should be denied. I also have to change the permission class attribute on the book view set. Change that from isAdminUser to my newly created isSuperUser. Here's the web browser again. I'm still logged in as Indy. Going to the Books API, and Indy no longer has permission. That's good. Let me just go back, log out, log in as admin, go to the Books API, and there's the listing. isSuperUser works. You can also chain permissions together. Let's add another custom permission, this time checking whether or not you're Indy. Same as before, inheriting from base permission, but this time I'm going to make a change. I'm going to override the hasObjectPermission method. This allows me to specify permissions at the object level rather than at the global level. What I'm going to do here is check whether or not the object itself, which in this case is a book, is restricted. So this is happening on line 17. If the book does not have the restricted flag, then anyone is able to see this because I'm always returning true. If you get to line 20, the book is restricted, and in this case it checks whether or not the username is Indy. If it is, Indy is allowed to see the restricted books. Everyone else is not. The other change that I have to make is inside of isSuperUser because I'm going to combine these two permissions. By default, inside of base permission, permission is granted. So if I chain isIndy with isSuperUser and I don't change the hasObjectPermission for isSuperUser, it will always be granted, which is something you have to be very careful with. Personally, if I were designing the framework, I would make permission denied be the default rather than permission accepted. So you have to be very, very cautious when you play with this stuff inside of the DRF. I have already shot myself in the foot several times with this particular feature, accidentally opening up permissions when I didn't mean to. Let me show you the change. Defining hasObjectPermission inside of isSuperUser. And setting the return value the same as hasPermission. So this makes sure that if the permission is being checked at the global level, at the request level, you check whether or not it is superuser, as well as at the object level. Finally, I'm going to update the permission classes, and I'm going to change this to chain the permissions together. You do this with the OR operator. Now, when someone visits the view, it checks the isIndy permission. If that passes, they are allowed in. If it does not pass, then the isSuperUser permission is checked. Back at the library homepage here, I'm just going to log out and log in as Indy. Visit the Books API, and you'll notice that everything here is listed. Now I'm going to visit a particular title by changing the URL to look at book number 2, which is a restricted book. You'll notice that Indy can see this. This is the expected behavior. I'm sure you can tell by the way I'm demonstrating this that there's a but coming. Let me log out and show you the problem. Logging in as Marion, visiting the Books API, and there's the problem. Notice that Marion can see everything, including the restricted books. So what happened here? Well, it is actually working. It's just that the listing and editing are different concepts, and the permissions only apply to the editing, not to the listing. The listing is done through a separate mechanism through your query set. To show that this is working, I'm going to visit the specific URL for Tanis and You. And because I'm logged in as Marion, I now get permission denied. So it's working, just not the way you might expect. So you've seen that the permission classes only affects whether or not you can actually touch the object specifically. It doesn't affect the listing. This is a little counterintuitive and unfortunately allows you to accidentally expose things through your API that you may not have intended. In order to have the behavior that I want here so that restricted books don't show up in the listing, I have to modify not just the permission classes, but also the query set. Here's a subset of the views class, just the view set. I'm going to change the query set now to include a filter. Inside of the query set, you can get at the request object, and you can decide who the request is for. In this case, I'm checking whether or not the user is staff. If the user is staff, then all books go back, no matter what, essentially ignoring the restricted field. Otherwise, so users who are not staff or not logged in, you will get a filtered version of the query set, and that filtered only shows the non-restricted books. Still logged in as Marion, clicking on the Books API, and now my book listing no longer has Tennyson U because it's restricted. So you've learned how to use permissions. More importantly, you've learned how to be very careful with permissions. First off, default permissions allow entry rather than deny them. That can be a problem if you mess things up. Secondly, permissions don't apply to filters. So if you want to make sure that only things with permissions show up inside of your listings, you have to do more than just set the permission. You also have to change your query set. There's a lot of power here, and I always hesitate when I criticize somebody who's written open source software because more power to them, we're all using it, and that's fantastic. That being said, you got to be a little careful here, or you'll end up with some toes missing. So that's the permission mechanisms. Next up, I'm going to do a deeper dive on serialization and show you how to do some fancier stuff.